What's up, guys? Welcome back to the channel. In this video, I want to talk about solving electrical problems, whether you're working on a trailer, mower, car, truck, whatever. This video is going to help. There's one thing that people often overlook, and it's very common. It costs no money. It's easy to do. We're going to talk about that. That will solve your electrical issues. And then also, I want to show you some tips on how to pinpoint exactly where your problem is with your electrical system. So let's get started right now, but do me a favor, hit that like button, hit that subscribe button. Let's get started. So this mower in particular had the perfect opportunity to show you two examples of what I'm talking about, and that is tight and clean connections everywhere. I can't tell you how many times I've solved electrical problems with a unit simply by tightening or cleaning connections. It's very important. What happened with this mower was the customer said the blades stopped cutting, and then once he cut off the engine, it wouldn't start. So I knew he probably had a charging issue. I've done a more detailed video. I'll put a link down in the description where I talk about checking your battery and your charging system, checking whether it's the stator or the voltage regulator. It looks like this on a lot of mowers. It's real simple. You'll need a multimeter, and most of the time it's that voltage regulator, luckily, and it's really easy to replace. It's just two bolts there. But speaking of that, on this unit, what I want to talk about is just signs where you have the problem. So I'm going to turn on this light here, and when I was changing out this voltage regulator, you can see how much heat I got on this little connector here. This plastic part slips up over right here, and you can see where it had burned up really bad. I've just got it slipped back on the wire right now. I'm going to replace that. But one thing I'm going to talk about is how loose this connection is. All right, so when something's that loose where it's just easily going on and off, you need to make sure it's nice and clean and tight. But the way you can tighten it up is this little tab right there that I can take a little flat blade screwdriver, pull this out into where it'll get a much better contact on that tab. Now, one thing I asked my customer to check was his fuses when I was on the phone, and he said both fuses are good. And so I'm going to show you the fuse that was in here. I can see how at first glance with certain type of lighting, maybe he was holding it like that, might have thought it was good. But you can see where it's burned right there. So the way my customer ended up potentially wasting a lot of money was he first replaced the battery because his blades had shut off, and then it wouldn't restart, where his battery might have still been okay, but he puts a new battery on it, spends $100, and it lasts for about half a day, and then the blades shut off because these electric PTOs draw quite a bit of battery amperage from the battery. So if it's not being recharged, that's the first thing that's going to shut off. And then when you turn the key off, it's going to probably not start up because the battery's drained, hasn't been replenished. So the next thing he did, once his mower didn't start, he went and put a $250 starter on there. So he potentially may have wasted $350 plus the time and hassle of him getting the parts and installing them himself. And then he's still having this issue where all it was we needed to replace the voltage regulator, tighten up this terminal connection, replace this fuse, and that was probably about $50 worth of the voltage regulator. So out the door, he's done. He's looking at probably 60, 80 bucks. Another thing, loose battery terminals, they can pop fuses and all that, and that's so common. I see people just come in and the connections are just loose on the battery, and stuff will intermittently work, and then finally it just won't start, and they bring it in, it's just a loose connection on the battery or dirty. So guys, real quick, I want to show you how important just being clean is, your connections being clean. Right here I have a washer, relatively clean on this side, haven't done anything to it, and on this side it has a slight buildup of dirt that's just accumulated. It's not really rust. And what I'm going to do is I'm going to use a multimeter, and I'm going to check to see if we have current if current can pass through, like right now, you'll hear a beep. We're checking for continuity. I'll get to that in a moment. So if electrical current would pass through this washer, it should beep, and we're getting nothing because it's dirty. Right here, you can hear it beep. But by simply cleaning it off with a wire brush, let's get it down, get a good surface there. Now it's clean enough. That made that big of a difference. Now we can have current through that. So I want to demonstrate how you can use this multimeter to pinpoint exactly where your issue is. A lot of these multimeters, you know, they'll be a little bit different depending on the make and model and everything, but basically what you want to look for is that omega sign and this little sign that looks like a signal, a speaker. That's the continuity. So it's going to give us a signal, that beeping noise, when we do have continuity, basically. And what I would like to demonstrate is, like, I'm going to take this washer and see that amount of corrosion right there. That's going to be enough to not let current go through. So I'm going to take a stack of clean washers right here, and I'm going to demonstrate how we can pinpoint exactly where our issue is. So basically what the multimeter is doing, it has a battery in it, and it's just sending a signal to the two terminals here, the two prongs, if current can pass through. So I'm touching this bottom washer here. We got our function there turned on. So we have a signal there, and let's say this was on the other end of where you think components are in between in the circuit, and you're not getting anything there, you're not getting anything there, you're not getting anything there, but you probably will right here. See how I'm getting signal there? And if I'm not getting it there, I know this is the issue. So if it's going this way, we got current here, current here, current there. Now we don't have current, so it must be that surface. Let's say you think you might have a broken wire. So I'm going to show you, you can use this continuity function on the multimeter to pinpoint your wires. Now this is just a short wire, for example, and nothing's wrong with this wire. As you can hear, we're getting our tone there. This one I purposely have cut, but I'm going to show you how a broken wire can cause things to just work intermittently. Like right now we don't have a signal, but if I just bend it, how just a cut or bent wire might look good from a visual inspection, but you might have an imperfection on it. That means when there's, you know, wires where you can't see them as easily, you can go ahead and confirm that you're getting flow. Just make sure you're on the same wire. So we just check the red one, we'll check the ground. So we know the wire inside of that we can't see is good. We know our connection, our tabs are good. Another cool thing is you can check switches. So we got just a simple light switch here. And by the way, it doesn't, when you're checking continuity, it doesn't matter which way you put these prongs. It doesn't matter. So I can just put these prongs, or you can get the ones that have the little clamps. That's handy as well. So I can just sit here and hold that right there. It's off, and then with the switch on, we should get tone between these two tabs. Turn it off, on. So you can switch, make sure that switch is doing its job with that continuity function as well. And guys, another thing I'll do is I'll use WD-40. It's safe to spray in electrical connections and things. I'll spray WD-40 in there. It helps loosen up stuff, and the mere act of just taking something in and out, or a little connection off and on, have some WD-40 on there, it doesn't hurt anything. I'll argue with you till the cows come home. It doesn't hurt anything. Blow it out with some air. The WD-40 does a great job. WD actually stands for water displacement, and the 40 stands for the 40th formula. It worked for what they wanted it to do, but it's great. It doesn't hurt, you know, paint or anything. It actually is a great degreaser too. Not sponsored, I wish I was. But anyway, it does great. Compressed air, gets all that gunk and grit and dust and dirt out of connections, and leaves like a protective film if you use WD-40 on there, and it just helps get all that rust away and make a good solid clean connection. So guys, that's going to wrap it up for this video. Just make sure all your connections are clean and tight. Look for visual signs of overheating, loose terminals, things like that. Use that multimeter and that continuity function to pinpoint where your problem is. And hopefully this video will help your next electrical issue solving job much easier and faster. Do me a favor, hit the like button, hit the subscribe button. Also check out, if you're looking for any tools, multimeter, whatever, check out my Amazon store. There will be a link down in the description for that. That's one way you guys can help support the channel. I'll get a small commission on that. But if not, just simply liking the video and sharing it, subscribing, commenting. Let me know if this has helped you out. Anything I forgot, leave it a comment down below. Thanks for watching, guys. I'll see you next time.